I'm going to talk a little bit about our nitrogen cover crop nitrogen availability calculator. I first want to give you just a second about Georgia agriculture, because we are incredibly diverse. Cotton, corn, peanuts, soybeans, good vegetable production, commercial vegetable production in the very south of the state, Vidalia onions, blueberries, not many peaches, a lot of chickens, and a lot of cattle. So very diverse agriculture and a lot of different needs from people. Very hot, humid climate in the south of the state. Soils are sandy. So in our agricultural soils, our organic matter is usually less than 1. And it is a challenge for us to boost that carbon. And if we don't have cover crops in our systems, we'll never get there. So that's one of the things that's been driving this work. The other thing is that it's great for us, and we know there's a lot of research out there saying if you'll do this and you'll reduce tillage, you know, you can really see a lot of benefits in 4 years, right? So that is a super hard sell. So we got interested in this nitrogen management aspect because we wanted to be able to make more concrete for our growers a short-term benefit. You know, nitrogen management for farmers using cover crops is problematic, right? Because we don't know how much they can expect. They don't know when exactly the nitrogen will be released from the cover crop. They don't know exactly if they take a nitrogen credit, how it's going to affect their yields. And the big thing, is it profitable, right? So what we wanted to do was try to come up with a better tool for our growers. It is complicated, right? Because it's affected by soil temperature and moisture. We think about carbon-nitrogen ratios a lot when we think about cover crop decomposition. But we also know that cover crop quality really affects the decomposition rate. So the amount of carbohydrates in a cover crop will speed up the decomposition rate, and they tend to be correlated with the amount of nitrogen in the cover crop. Well, that makes sense because it's related to growth stage a lot of times. The amount of lignins, tannins, polyphenols, stuff like that tends to slow it down. So all of these things are related to the species, the varieties like Chris was just talking about, your specific weather conditions during that year, and this thing about growth stage. And that's something, as an extension person, I've found that it is an area that farmers don't think about a lot. I don't know if we haven't talked about it that much, but I think they don't think about how that affects nitrogen release. This is an example, and this is when I really realized that people were not thinking about this. This is a cotton farmer that I've worked with down in South Georgia. And in 2015, you can see he planted oats. This guy has his own poultry houses, so he uses poultry litter a lot for fertility. And those oats can scavenge a lot of nitrogen. And so you can see in 2015, we had pretty good biomass, but he killed them right after we sampled in that top picture. They were just headed up. And you can see the nitrogen content is pretty high, and the carbohydrates, you know, are okay. The lignin content is pretty low. And there was over 160 pounds per acre of nitrogen in those oats, total nitrogen. Now, we predicted that he would get about 60 pounds of nitrogen released over the growing season from that. For cotton, he doesn't need to side dress. For cotton, if you get too much nitrogen out there, you're spraying growth regulator all fall, trying to keep that stuff from getting taller than me. So we put in test checks there, where he did his normal nitrogen management thing. We used our credit calculator, and there was no lint yield difference there. This guy was super excited about it. His crop advisor super excited about it. They decided they wanted to do it again the next year. For whatever reason, I kept calling saying, when are you going to terminate? When are you going to terminate? When are you going to terminate? He went really, really late. The second year, he was in soft dough. I think some of it he was going to harvest for seed, and that's fine. But from the nitrogen perspective, we've got a lot more biomass, but the concentration was lower, a little bit lower total nitrogen content, but only 25 pounds of that is going to be released in the first couple of months of the growing season. So, really big difference because of the choice of management there. And that was something that he had really not thought about. I'm from the South. Thinked about. All right, so this is our approach. Dr. Miguel Cabrera and Dr. David Kissel have been working on this nitrogen subroutine that's part of the series crop model for many, many, many years. And they've done all the, how much goes to soil organic matter and how much is mineralized and how much goes here and how much goes there. And they were interested in farmers being able to use this. And I said, well, great. People want to know there's a process behind it, but what they really care about is, if I use this, am I going to get a yield difference? So that's how I got involved in this. And so what this thing does is we get the user to take a wet cover crop sample in the field, and we have a couple of extension bulletins out there telling them how to take biomass samples and how the calculator works. We send a subsample of that to our feed and water analysis lab, which will give us total nitrogen, carbohydrates, cellulose, and lignin. We have a weather network that we can pull in soil moisture and temperature with, and then we can predict these nitrogen credits or debits if it's going to immobilize for them, and then we can give them a release curve. So what makes this possible is that what we've been able to do for cover crops is tap into the forage and feed consortium testing, and they have tens of thousands of data points where they have correlated NIRS reflectance to crude protein. It's the stuff they need for forage quality prediction. Crude protein, acid detergent fiber, neutral detergent fiber, lignin, and ash. And what we do is take those correlations and switch around some calculations, and I'm giving you these here, to predict the non-structural carbohydrates, the cellulose and hemicellulose, which we just call cellulose. We get lignin from the NIRS, and then we can get percent nitrogen from crude protein. And if you want to ask me about this later, you can, but those are the formulas up there. And then we pull in, we've got these weather networks all over the state, so they just pick the closest weather. So this is pulling on a 5-year average, right, of soil temperature and soil moisture, because I can't predict forward, so I'm using the last 5 years for what's there to give them these predictions. We can pull in weather data from other systems. We're working on that to move forward. Kyle? So this is what it looks like. And this is what it would look like on the web if you wanted to go in there and play with it, or if a farmer wants to go in there and play around with biomass numbers or things like that and see how it affects. But you can see they pull in the data from the lab. We've got a crop in there. This is some work from the horticulture farm. In this case, it was broccoli. When they put in their crop, it pulls in through our crop codes what the target nitrogen rate should be. For us, for broccoli, it's 150 pounds per acre. It asks them what the planting date is. This is a fall broccoli planting example. We had cowpeas as our summer cover crop, and then it asks you when the cover crop was killed or incorporated. So then the next thing that will come up is that they have sent you in their submission form their wet weight biomass on a pounds per acre, and the lab gets percent moisture and calculates dry biomass. The NIRS gives us the percent nitrogen, the carbohydrates, cellulose, and lignin. And then this is what they get. So it comes back to them and it says, okay, you had your cowpeas, they were terminated on this date. It's predicted to release 72 pounds per acre. And then in the first 2 weeks, you're getting 29. In the first month, you're getting about 60 pounds. So it tells you your target nitrogen rate was 150. From that, we were getting about 50 pounds per acre. So this is, his graph showing it. This is for cotton again. We're just going in and we're saying, okay, we've got 3 strips. You do your regular nitrogen management here. We'll have 3 strips where we'll take the credit and look at yields. This is some of the results from the broccoli, and I'm showing you both the results from the Hort Farm, which is a complete research thing, and some of our on-farm trials. You'll notice that this is all organic broccoli, and you'll notice my yields are not that great. This is a one-time harvest. We just came in and did a one-time harvest instead of like many of our small growers would harvest several times and get side shoots. And I think that's why our yields are a little bit lower. But basically, I think what you see is that there is a lot of variability on there, but we are getting either similar or better yields where we're using our nitrogen credit than when they're using a full nitrogen recommended rate. One thing I'll point out on the Hort Farm is that first year in 2013, you see we did a whole lot better with the cover crop than the regular. That was a certified organic ground, but it had just been transitioned in, and we did not have the soil quality really built up there, and we saw a much bigger cover crop response there. By the time we rotated out of that field for 2014 and 2015 into another area that had been managed organically for 8 or 9 years, much higher soil quality, and you didn't see as big a cover crop response there, which I think makes sense from a soil scientist's point of view. Similar on farm, in general, we got the same yields, and I guess my stats from the Hort Farm, what I'd like to point out is that we did, get a nitrogen response there, and we're not seeing a difference, like we're not seeing that interaction between the nitrogen fertilizer and cover crop, which tells me that that credit is, it's working, what we're doing. So I've got all these different types of production systems, and the question was how to get at this. Is it working? And so I'm a pretty simplistic thinker, being an extension person, and decided, Chris is the one that does all the fancy statistics, right? So I just decided, all right, we'll take the yield with the cover crop credit, and we'll divide it by the yield at the full nitrogen rate and look at that ratio. And if it's close to 1, then we're doing pretty well. Now, those of you all who are in this field know that yield is affected by a whole lot of other things other than nitrogen. So it's kind of a funky way to look at things, but it's also what the growers are really interested in. And I think you can see from our curve, and our average ratio is very close to 1, that in general, it looks like this thing is working. All right, so I thought you might be interested in some of this NIRS data, and looking at some things. So I've given you some ranges and things up here, both for the summer legumes and for the cereal rye, and you can see, you know, you can get pretty high nitrogen concentrations with it from when it's young, and some of the mixtures. But then you can see, I guess the take-home point of all this data up here is just what Chris was saying, is that how much available nitrogen you're getting out there is driven by biomass. If you've got 4% nitrogen and you've got 500 pounds per acre, who cares? It's just not going to be very much. So it really is biomass driven, and that's why you can see huge ranges in some of the predictions, like that COSAC Austrian winter pea, 15 to 83. It's really going to depend not only on biomass, but there. One year we had the Austrian winter pea melt from Sclerotinia, and one year we had really nice production from that legume. Okay? So I feel like that in general, this is a conservative way for farmers to get a better handle on this. We are just dealing with above ground biomass. I was talking yesterday with Doug, and I think the big white elephant or whatever it is in the room is what's going on with the soil and how much is being released there. And I just don't think we've got a good way to get a handle on that yet. But this is a step in the right direction, and our results have worked very well, as you can imagine, with incorporated residues. We've had not quite as good results when it's left on the surface, and we are in the process of revising that in the model. The model is driven by soil moisture and temperature, and as you can imagine, when the residue's on the surface, that might not be the total driver of decomposition. So we're doing some work now to try to loop in the humidity with soil moisture and the air temperature to drive those surface decomposition dynamics. I think the thing for me is it has been a great educational tool. It's been a kind of a way to concretize, if that's a word, for folks what's going on out there and how these cover crops are working. So I wanted to show you some examples. This is where we started, and I know it's kind of hard to see, but the series nitrogen subroutine actually predicted soil nitrogen mineralization. But some of our validation work showed that that wasn't working as well as what we would like to see. But this was actually one of my big mistakes. That's why we do research. I had a Sudan sorghum cowpea mix that it was in this really good organic soil, and the Sudan sorghum totally took off, and the cowpeas were non-existent. And I was asked by this research project to do the fertility, and I had just sort of like, okay, yeah, we're going to get 45 pounds of 50 pounds of nitrogen out of this cover crop based on the, the cowpeas, whatever. And that's what we assigned. And then our carrots did abysmally. And part of it was the nitrogen, and part of it was that Sudan sorghum allelopathy. I don't think we waited quite long enough. But you can see, so I went to Dr. Cabrera and got this tool, and you can see we predicted with that much biomass with that tool that we were going to get a mobilization. But that was after we already planted and fertilized and everything. So this is what got me interested in it. So we decided to focus on the cover crop part and not the release from the soil, and gotten what we showed you. I wanted to show you some results. I've actually got farmers using this now, and I wanted to show you some results. This is a guy down in South Georgia, And he has a cereal rye, hairy vetch, crimson clover mixture. So from that, we were getting about 50 pounds per acre. And so this is, his graph showing this is for cotton again. And it's showing you that we've got that pretty steep release. Most of that nitrogen is being released before he's planting. So in that case, probably what I would do is say, okay, maybe you could drop back on your planting nitrogen, but you probably still want to side dress it pinhead square, okay? Because it's leveled out by the time he gets to that in 6 weeks or so. All right? So this is the same guy, and he planted pure hairy vetch. And look at this. Here, it's almost 100 pounds of nitrogen out there. But again, look at it. It's just like, wow, going up to everything that cotton needs, but it's before he plants. So this is a tool that we can use with growers to help them tweak their crop advisors to help them tweak their nitrogen management and better understand how cover crops can be used to help them with that.